Nice. What did you for states? You said. Okay.
And I put my chapstick on that.
That's fine. I can also solve a Rubik's Cube one-handed, blindfolded, and with my feet. Too many people talking at once. What's going on? I don't have one to solve.
I know you have one in your dorm.
No, I don't. They're all broken. Sure.
Yeah, me too. I'm going to bring mine.
But anyway.
How about we solve both of them? Like this?
Yeah.
No, technically, if you're right, for solving one-handed, you technically should be using your non-dominant hand, because for some reason, if you're right-handed, you can solve it a lot better using your left hand.
Really?
Yeah, and if you're left-handed, same thing with you. It's a little unintuitive, I know, but when you're solving it, trust me, for me, I'm right-handed. It makes a lot more sense for me to solve it with my left hand than it does my right hand. Yeah. I also do have an official solve with my feet.
What?
Yeah. I don't have anything on video, but I do have this. Hold on.
Can you make like a censored version?
A what?
Censored version. I don't want to see your feet. I want to see you do it, but I don't want to see.
No, thank you.
You can get a pedicure.
Already have.
Was it nice?
It's wonderful.
You got them?
Boom. There it is. One solve with my feet. 6 minutes.
That's how. That's so hard.
Yeah. At the Meadowlands 2018 competition. So this conversation went off the rails. Anyway, back to this. Anyway, no. Ladies and gentlemen, I want to pick up kind of where we left off to an extent.
Does anybody remember where we left off?
I do.
Well, that wasn't.
I say kind of where we left off because let me just give you a recap of what we did before break. Before break, on like that, I had you Monday, Wednesday before break. On that Monday, I did some basic reintroduction to some factoring of quadratics, basic reintroduction to the Tucker method. But then on Wednesday, we were forced to take the benchmark, if you happen to remember. I know it's been a while. That's why I said kind of where we left off. The benchmark being done and done, hopefully being done and done, my supervisor being satisfied with whatever the heck scores came up. We are going to continue in this brand new chapter that we kind of started right before break. Keep in mind one thing. April 1st was the end of the third marking period. April 1st. April 15th is when grades are due for teachers to submit them. Now, this doesn't work for every teacher because I don't know what every teacher's rule is. But I posted something in Google Classroom on April 2nd for you all. Hopefully you read that, where I said, attention, teachers are required to submit grades before April 15th, and we're currently on spring break. This translates to you having some extra time to get some things turned in. I am in no way done grading things, so do not worry if Genesis isn't updated quickly. Email me if you have any questions, but keep in mind emails won't be checked frequently. I put frequency, that's weird, frequently in the next week. I know, right? And they're going to England. Come on. Anyway. But my point being is this. I don't know what it is for other teachers, but grades are due by the 15th. I have to click submit on the 15th. I believe so. I think it's 8 a.m. Yeah, usually they delay it to like 2 p.m. for some reason, but that's like by print. What I'm trying to say is if you still have things you owe me and that you can and you can get them into me sooner rather than later, that would be to your benefit.
So you are something more.
Yes, which is why I said it translated to more time. So if you do have questions, make sure you're emailing me. I have about 100 or so emails to catch up on in my inbox because I didn't check anything over break. And yeah, here we are. So other thing I want to talk about, what is happening in 2 weeks? Not related to academic school stuff. No. In 2 weeks, they changed the schedule. I'm not the one doing it, but I'm just letting you know they changed the schedule in 2 weeks. It's above my pay grade. It's not my job to make those decisions. Oh, no, I can say whatever the heck I want. Yeah, I just choose not to.
So what's your opinion?
I don't have to share anything with you guys. It's like that feet thing earlier. That was weird. You know something weird? Several years ago, it was like February of some year. I can't remember what year it was. My wife had gotten a coupon, not a coupon, like a certificate to go get like a free pedicure or manicure. And she's just like, come with me. It's for 2 people. I'm like, all right, sure. Pedicures are the best. Let me just tell you.
It tickles.
I'm just saying, they're the best. If you haven't gotten one, I'm sorry. You need to get one. So my wife took a picture of me sitting in the chair getting my pedicure done. And I thought, that's a great picture. So I posted it to the Google Maps site of the nail salon. It took Barnegat High School students 3 months to find it. And once they did, people were like, oh my gosh, have you seen it? And they're like retweeting it like crazy. Have you seen this picture? Blah, blah, blah. And kids are coming up to me like almost apologetic. Mr. Markey, did you know that this photo was there? I'm like, yeah, I put it there. Do you like it? So just super funny. It has over a 250,000 views.
Yes.
Just saying.
Honestly, Mr. Murphy, you're my
I don't know where this sentence is going.
I was gonna say spirit animal, but you're not an animal, so that doesn't really make sense. So maybe you're just like my
I'm sorry. Those are acceptable statements.
That's
I'm sorry. You should come by the cryptology class more often. I'm just saying.
You're my guardian angel.
Okay. Wow. Acceptable. Anyway, so if you would, in order to get back into what we need to do, because we still have a couple chapters left to go in this school year. You know, you're 75% done with the year. Insane, but we got still more work to do. So if you would, if you do not already have them out, I'm gonna need those notebooks out and open. You didn't say it right. Make a t-shirt? Probably. I'd make more money. If in the chat you have not left a comment, I see a bunch of comments right there. If you haven't left a comment, please make sure that you do so. That'd be fantastic. No, you're here, so you don't have to. But I'm gonna need those notebooks out and open. Sure, give me a sec. No, it says Monday to Friday. Yeah. Let's duplicate that screen. For those of you in the chat, I am going to be opening up the YouTube chat so I can see it. There we go. And let's start here. Sorry. So today is the 12th, and we are calling this Simplifying Rationals. Rationals. Over the course of this chapter, we are going to be doing a number of different things to what they call rational expressions and rational equations. These rationals, after simplifying them, combining them, finding like terms for them, multiplying them, doing all these different things to it, eventually we are going to get back to graphing them. And if you happen to remember the graphs for some of these things were absolutely ridiculously insane. Just as a visual to what that thing kind of looked like, give me a number. Too big. Yeah, a single digit number, positive or negative? 8 plus 8. And then give me another one, but make it negative.
Negative.
All right.
Or is that going to work, or do you want a different number?
Oh, this will totally work.
Oh.
Look what we got there. I changed the window a little bit. Let me change the...
Does anybody have a pencil I can use?
I do. They're up there.
You're talking about those little ones.
Yes.
I'm purposely not using them.
Sorry.
I'll give it back. I'll even stand up my little ones.
Yeah, they got little ones up there with eraser caps.
But
Why would you use those?
if they're
Yeah.
pencils, is that
Yes, they are golf pencils. So anyway, this is what these graphs technically look like, which they're weird. And they could actually end up looking a lot weirder. As I've shown you before, let me actually raise this to the second power right here, just for funsies. Minus 8 parentheses graph. Look at this thing.
Oh my god.
Just insane. We're going to end up graphing stuff like this. But before we get there, we're going to have to take that route of simplifying rationals. So let's start with an example like this.
Before you start, did you have a good spring break?
It was acceptable.
Okay, perfect. I'm sorry to hear that it wasn't.
So let's look at something like this. Now, I put this example up here for a very specific reason. This example, we are going to have to simplify. But I need you to know something right off the bat. You have always been taught what happens when you divide something by itself. Right? It can't, no, 1, it would cancel, right? Yeah. But here's the thing. And I'm going to explain why, and I will explain why in a few moments. But this 3a squared and this 3a squared do not cancel each other out. Now, let me repeat this statement. You have always been taught, hey, something divided by itself, it's 1. They cancel each other out. Yes, and that is still true. But you should know that this is not 3a squared divided by 3a squared. This is not. See, because when it comes to simplifying these types of problems, you have to know that you are not allowed to cancel these two things out if there is addition or subtraction separating that term from the rest of the problem. Let me repeat that. You cannot just cancel these out because there is addition or subtraction separating them from the rest of the problem. It's a 3a squared minus, and that minus does not allow you to just straight up do this. You can't do that. You're not allowed. That plus sign on the bottom, separating the 3a squared, does not allow you to do that. You're not allowed. That is an illegal math move. It is a sick bird. Same thing with the 24 over the 12. Can't do it. Same thing with the a over the a. Can't do it. Because there are invisible parentheses separating the tops and the bottom of the fraction. And because of the parentheses, because of the plus and minus that are in there, you cannot just cancel things out the way that you want to. So how do we simplify? You need to factor. Now, I know it's been a while. Like I said, it was the Monday before break. The Monday, I don't even have March up here anymore, but the Monday before break, I believe it was the 30th maybe, or the 29th. I have no idea. We went through a series of factoring, showing you how to factor, reintroducing you to factoring. And I will tell you the first step in factoring that you absolutely need to remember is GCF. What the heck is GCF? You need to know that. You need to know how to do greatest common factor. So I look at these two terms right here, the 3a squared and the 24a, and I ask, what do they have in common? What do they have in common? What are they both divisible by? They're both divisible by 3. Now, that's a common factor, not the greatest common factor. What else are they both? What? No, not for this one. What are they also both divisible by? Definitely a 3, but also notice the variable. 3a. Watch how we're going to write this. 3a factored out as a greatest common factor. If I divide, because you said divisible, if I divide both of those terms by 3a, the first term divided by 3a leaves me with an a. The second term divided by 3a leaves me with a minus 8. Now, the whole idea of factoring is breaking these things apart. I knocked out the greatest common factor. Notice, I don't have a quadratic anymore. I'm technically done with factoring. If you had a quadratic or a cubic or something along those lines, you may be able to factor farther, but in this one you don't. So, okay. So I go to the bottom. The bottom also has a 3a in common. And if I divide both of those terms by 3a, say again? Not minus. Exactly, because of the plus sign, right? Now I go back up to the board, dramatic fashion, walking, holding up the red marker. I'm reading the stage directions. I told you before, you are not allowed to just cancel out these 3a squareds because there is addition and subtraction separating them from the rest of the problem. Tell me, what operations are surrounding this 3a now? What operation is directly below it? What operation is directly below it? It's just division. And what operation is directly next to it? Multiplication. Even though you don't see the symbol there, it's still there. Same thing with the 3i on the bottom. You are not allowed to cancel them out here because of the minus and the plus. You are allowed to cancel them out here because they're only being separated by multiplication and division. So, I cancel. Oh, Ms. Ranky, what about the a's? What about these extra a's? Sorry, can't do it. This is an a minus 8. And this is an a plus 4. They are not the same term. And as a result, the simplified version of this problem is literally just that. You cannot simplify any farther. Now, I've seen a lot of people try. I've seen a lot of people mistakenly try to simplify that farther. They say, I'm just going to cancel out the a's, and -8 over -4 is -2. And I say, no, you are not allowed to just make that a -2. That's a sick bird. That is an illegal move. Yeah.
So the reason you can't do it is because there are the parentheses there, so it's one whole equation instead of separate little things.
Technically, yes. This is a minus 8, which we don't normally put the parentheses, but you could. You absolutely could. And this a plus 4. The a minus 8 is a term that would only cancel out with another a minus 8. Well, right now they can't because I don't have an a minus 8 on the bottom. You're going to see some other examples where stuff does cancel. But we'll get there. We're going to build up to that. You're going to see. It's going to be nice. Here's the simple rule. If the term is separated by multiplication division only, yes, you can cancel it out with something top and bottom. If the term is separated from the rest of the problem involving an addition and subtraction sign, sorry, no, you can't cancel it out. But we can force it to by factoring. Let's see what we got next. The microphone. I mentioned that picture on the nail salon website or the Google Maps thing. One year, one of my classes, I don't know where they actually did it, but they printed out like dozens of color photos of it and posted around my room around April Fool's Day. It was the greatest thing ever, except I wasn't there that day. I was absent. The substitute thought it was mean and tried to take down as many as he could. So when I came back the next day, I only found 4 of them. And every time I found a new one, I taped it up on my wall behind me. It was so great. Hold on, I think I still have it. Yeah, here's one of them right here. It's amazing. Yeah. I still got the tape on there. I taped it up on the wall. But you can see, hold on. I found, I only have 3 of them. I got 3 of them. So, amazing. But I don't know how much they spent on printing. Because like printing out color photos can be expensive. All right, let's try this one. 21 x cubed y divided by 14 x squared y squared. What do you notice about this problem compared to the first one that we did? Besides the fact that I'm using different letters. There's no plus or minus. There is no plus or minus whatsoever. Meaning the only operation that I have is multiplication division. Yes. Yes, you do. This is perfect. If there's only multiplication division, that means that I can cancel stuff out the way that I want to. Yes, you can. Yes, you can. Now, I'm going to show you the long way and the short way to get this problem done. Both ways are acceptable, but let's just see what happens. Can you break apart that 21? How do you break apart that 21? Factor it. Or factor tree, or whatever the heck you call it. I don't know. Sure. 3 times 7. What the heck is x cubed? If you broke that thing apart. It's not just a single x, though. What does x cubed actually mean? That's what it means. And then there's a solo y right there. All right, that's the top of the fraction. Let's go to the bottom. I'm going to do the same thing. 14. Isn't 14 just what, 2 times 7? Cool. 2 times 7 times... Yes. Because it's squared and squared, there's only 2 of them and 2 of them on the bottom. But again, as you pointed out, no addition, subtraction. There's none. So am I allowed to cancel out these 7s?
Yeah.
Yes. Short answer is yes. Because only multiplication division separates them from the rest of the problem. Only because of that. The 7s cancel. Oh, check this out. These 2 x's and these 2 x's cancel out 1 for 1. This singular y and this, well, it doesn't matter which one. You just pick one. I don't know, the first one. This singular y cancel each other out.
3x over 2y in exclamation point.
Well, I wouldn't put an exclamation point. That means something else in mathematics. Huh?
In math?
Yes.
Really?
Yeah, an exclamation point is referred to as a factorial. So if I said something like 4 factorial, that would actually be the calculation 4 times 3 times 2 times 1.
Okay, so we'll do hashtag x over 2y.
Hashtag. That's a number symbol. But anyway,
Well, we can look at it as a hashtag. We can even write hashtag out.
I think it's called an octothorpe.
Yeah, it is.
Yeah.
That is right. And one singular parenthesis is a parenthesis.
All right. You know, the word data is plural. When you say the data, you have to say the data are.
Is that all? Wow.
It's really messed up. Now, that's the long way of doing things. Here's a little bit of a shortcut. And again, you don't have to do it this way. I just want to show you in case you decide you want to do it this way. Now, again, what I'm about to show you technically can only be done because of the multiplication division that's present. Only because of the multiplication division. Addition, subtraction, you wouldn't be able to do this. What number divides out of 21 and 14? What are they both divisible by? Simplifying regular fractions like you were back in 5th grade. I'm pretty sure it was elementary school. Can you simplify 21 over 14? What can you divide out of both numbers? Yeah, 7. So it's like, oh, divide by 7, divide by 7. Okay, almost there. I literally just divided both by 7. Can you simplify 3 over 2 any farther? Nope, leave it. Again, only because of the multiplication division. Only because multiplication division is the only operation that's there.
Well, I mean, technically,
Well, it'd be a decimal, 1.5.
yeah.
Yeah, but I'm going to leave it as is.
Well, you asked. So
I did.
technically we can.
Question, how many x's are being multiplied on top? How many x's are being multiplied on bottom? Now listen very carefully to how I word this. If there are 3 x's being multiplied on top and 2 multiplied on bottom, if they went to battle, who would win? The top one, right? By how many? By 1. The top would win by 1. The top x would win by 1. Who would win between a battle of the Y's, top or bottom? By how many? Done. Sometimes seeing the top version right here, the version that I wrote out log-wise, is nicer because you can actually see things canceling out in a concrete way.
I thought you said the second one was longer.
No, the second one was a shortcut. Second one's a shortcut. Sometimes you got to learn to crawl before you run. You know? Kids aren't like baby horses just getting up and walking after being born. You know they do that? Yeah, it's pretty crazy.
What about giraffes? Because giraffes have really long legs, so when they give birth, doesn't it just like plop down?
You ever seen giraffes fight?
No. Do they smell like swords?
Well, they smack their necks together.
Yeah, so like swords.
Anyway, what a day.
It's 'cause I'm here.
I'm pretty sure it's because I'm here.
No, I think it's 'cause I'm
Wow, that hurt my heart.
here. No, Mr. Murphy, together we make a dynamic duo. Like we could stop world hunger or something.
I'm pretty sure we can't.
No, we can't. But we can. We honestly, yeah, no. We could do math though.
Brand new problem. Now, I'm looking at this problem. I see on the bottom, okay, I got an x minus 2 and an x plus 1 on the bottom, but they are being multiplied together. So I'm just going to put a little multiplication symbol there. The x squared minus 4 on top, well, there's the subtraction symbol right. I don't know what to do. I'm just going to go back to sleep or go back to spring break. What the heck do you do here? Gosh.
Just give up.
No, we can't give up. You already are sitting down.
Look at the multiple choice and see which one makes the most sense, and then go with that one.
But there's no multiple choice.
Okay, then write the right answer.
I'm going to give you a side note, and I'm literally going to write it on the side. Side note. You know, math is very much like an onion.
Makes you cry.
Yeah.
Multiple layers.
Yeah. I got nothing else.
Makes your breath smell bad. I don't know.
They taste delicious. You got to cook them, though. My father-in-law eats onions raw.
That's disgusting. That's like Shrek, bro.
Yeah.
Why would you ever do that?
I don't know. He was on a kick where he wanted to eat like the most unprocessed foods of all time. So he would like eat like raw vegetables. Yeah. Anyway, back to this. Side note. X squared minus 4 is in the form ax squared plus bx plus c. It is a quadratic. And we can factor quadratics. If you go back to the lesson that we did the Monday before break, and again, this is why I tried to remind you of it a little bit at the beginning of class and at the middle of class. The Monday before break, I spent an entire class period trying to reintroduce you to factoring. I reintroduced you to the greatest common factor. I reintroduced you to the Tucker method. Now I look at this problem. X squared minus 4. Please note that this is a 1x squared minus 4. And notice that the term in the middle, the bx, is missing. If the bx is missing, what is the value of b? Yeah, and that's going to be important in a few moments. B is equal to 0. Going through the Tucker method, A times C. A times C here is actually a 1 times -4 because that B value is not there. So I get -4. Now this is where it comes in handy. Again, reminding you of the Tucker method. Can you tell me two numbers that multiply to A times C and add up to the 0 of B? Two numbers that multiply to -4 and add up to 0. Sure, -2 and 2. Those are my two magic numbers. Two magic numbers. I go to my T-chart. This is a 1x and a 1x. I put my magic numbers in the bottom. Nothing simplifies, but I end up with an x minus 2 and an x plus 2. Again, it doesn't have to be the Tucker method, but you can factor any which way you want. Absolutely.
What's the way with the, I think it's the X. Is that what it is?
I've seen people use the x before, but the problem that I have with the x is that it doesn't seem to work if this number is like a 2 or a 3 or a 4 or some junk like that. It's very weird. I've had people like, because I never taught the x, but other people like, I love the x. I'm like, all right, cool. Do you remember it? Like, yes, I remember the x. I'm like, hey, if it works for you and you want to continue using it, I have no problem with that. As long as you can show me the work. If you can show me the work, we're good. We're totally good. But that's the key. You got to show me that work. I've had a lot of people try to fake factoring using whatever websites they have, using the most convoluted methods of grouping that they could never replicate on their own. Oh, I know when you guys are using those websites. I know I can pinpoint exactly which problems you use those websites on. You need to know how to do this on your own. Go ahead. That's not an excuse. Now, why did I go on this long side note? Here is the reason. I went on this long side note to factor the numerator, x squared minus 4. Because the top of this fraction is actually equal to the following. And the bottom of the fraction remains the same. But now here's what I need you to recognize. Here's what I need you to recognize. Assuming that you are able to factor the numerator, assuming that the numerator of this problem is factored into these two terms, which they are, and now I've replaced them right here. Notice, what is separating that x minus 2 from the rest of the problem? Well, what operations? What's separating that x minus 2 from the rest of the problem? And? Yeah. And what's separating this x minus 2? Same thing. Here's the wonderful thing that you can now do. If you can factor successfully, if you can break these pieces apart, they can cancel each other out now. They can successfully cancel each other out. Because if you take something and divide it by itself, it should cancel to give you a 1. Resulting in an x plus 2 over x plus 1. It's really messed up. I'm going to show you something on the calculator in a moment. I'm going to show you something on the calculator. I just want to leave. Why? Ah. Well, let me show you this. This is the problem that we just did. X squared minus 4 divided by, now I'm going to have to actually do a double set of parentheses here. This is a little weird.
See, it just makes things so confusing. There's so many colors.
Well, I'm not worried about the colors right now. I'm just worried about the fraction.
There's blue, red, black, green, and orange.
Well, can you agree, though, that what I've typed in is the problem that we just did?
Yes.
Okay. Now, let me graph it, and let me try something. Graph. Woo! There's the thing there, right? Now check this out. Second equation. X plus 2 divided by x plus 1. This was our simplified answer, correct? That's nice. Check this out. Now it's going to be, I know you're talking about the colors. It's going to be red. Graph. What do you notice?
They're overlapping.
They're overlapping.
They're the same exact thing.
They're the same exact thing.
They're simplified.
Yes,
We're simplifying rationally.
exactly. That's literally what we just did. We literally proved that this equation is the same exact thing as this equation down here. It's insane.
That makes no sense.
Well, it makes dollars.
It does make sense, but it's just like annoying.
Yeah. See, the thing is, have you ever seen somebody in like an art class make like an elaborate painting that you look at and you're just like, this is amazing. This is so good. I could never in a million years do something like that. But then like the person who did the painting is like, well, you could learn how to do something like that. You know, it seems complicated, but to the person who has learned how to do it and has learned how to not be an expert at it, let's say, but it seems like, oh, this is so simple. This is so beautiful. This is so wonderful. But then, you know, I look at math as an art form. And even if it's like, oh gosh, I don't know how to do that, you can still come to a point where you can appreciate it for what it is. Just like a painting. It's insane. It's a philosophical thing, really. I want you to try a couple problems. I'm going to give you a few minutes, maybe about 5 or so minutes or less, to try the following problems.
Problem 4.
Yes.
You're giving us less than 5 minutes?
Yes. Because some of these problems will take you 30 seconds. There's the first problem right here. Let me zoom in right there. It is a 5ab cubed divided by, it'll focus, divided by 25a squared b squared. The next one. The next one is an 18 divided by 2x minus 6. I have suggestions that I'm going to give you on each problem. And then I have the following. That one will take a few extra minutes. But let's talk about what you can do before I set you off on these problems. First of all, ooh, that's a 10. On the bottom right?
No. Upper right. Is that an 18 or
18. 18. Couple of suggestions. First of all, on this problem, do you have any addition or subtraction?
No.
Nope. And since you don't have any addition or subtraction, there's nothing to factor. You can begin canceling things out the way that you kind of believe they will. Yes. Second problem right here. You can take out a greatest common factor out of the denominator? You can. This problem. What would be best for this problem is two things. Number one, parentheses around terms like that, and realizing that you have to factor an expression like that. How do you multiply fractions together? I did not teach you this. This is like a pre-algebra elementary school thing. How do you multiply fractions together? That's a common misconception. Butterfly is when you have something like this. Well, not necessarily if something's missing, but when you have an equal sign. This is where you would do that butterfly thing. Yes, cross multiplication. But when you multiply fractions, you multiply across. Top times top, bottom times bottom. Per se, I want to see what you can do. Take the next 5 or so minutes. I might give you a little bit less. Knock out these 3 problems. See what you can do with them. Let's see what we got. First problem was 5ab cubed over 25a squared b squared. Now, there are a number of different ways of handling this problem. Let me show you the longer way just to see the nuts and bolts and the mechanics of it all. First of all, 5 can't be broken up. A can't be broken up. But this b cubed can be broken up. Well, why am I putting the cubes there? It's really just b times b times b. There we go. On the bottom, 25 can be broken up as 5 times 5. A squared is just a times a. And b squared is just b times b. The only thing separating every term is multiplication or division. As a result, yes, I can cancel out those 5s, but that extra 5 on the bottom remains. This a on top cancels out with this a on bottom. 2 of the b's on top cancel out with 2 of the b's on bottom. What's left on top is simply a b, and what's left on bottom is a 5a. That's the only thing that is necessary for that particular problem. Again, there are multiple ways of handling it. There are multiple ways of getting this problem done. One way of doing the problem, 5 over 25, reduces to 1 over 5. And yes, technically that is a 1b over 5a, but that 1 is not necessary to be written. It would be perfectly acceptable, because technically it would be 1 times b. Same thing if you wrote the exponent. If you wrote the exponent, it's also acceptable to write an exponent of 1, let's say. Second problem. 18 over 2x minus 6. Now, as I suggested, I said, hey, factor the bottom. Factor the denominator. Take out a GCF, which in this case, the GCF is 2. And if you take out a 2, you are left with the following. Notice the 18 didn't change yet. But now, look at the 18 and the 2. The 18 and that 2 are now being separated by nothing more than multiplication and division. Whereas before this 2x was being separated by subtraction. Once you take out that factor, and once that factor is only separated by multiplication and division, then you can do the following to get the final answer. Notice something. 18 over 2, yes, reduces to 9 over 1. Mr. Markey, can't you do anything with this 9 and this 3? No, you can't. Because that 3 is being separated by addition, subtraction. It can't simplify. The only way that 3 would simplify is if there was another x minus 3 on the top that was also being separated by multiplication division. You can't do it. This is it. This is the simplified version of the problem. Weird. Then we come to the last example I had for you. And this is what we're going to wrap up today with. 5r squared over r squared minus 4 times r plus 2 over 10r to the 5th. Check this out. First and foremost, I'm going to write the problem like this. First and foremost, I'm going to write the problem like this. This is what I said, or this is what I meant when I said Multiplying fractions means you multiply across. Top times top, bottom times bottom. I haven't really done anything yet. On purpose, I haven't done anything yet. But I just wanted you to see top times top, bottom times bottom. This is why I suggested putting these in parentheses. Next, I suggested that you factor this r squared minus 4. Now, if you notice, I gave you a problem with the exact same quadratic as the side note from earlier. It's the exact same quadratic, except instead of x, it's r, which means I can do the following. The top doesn't change, but the bottom becomes this. The bottom becomes that. Now, junk is going to cancel out. Yes, the r plus 2's will now cancel each other out because they are being separated by multiplication division. Yes. That r minus 2 on the bottom sucks to be him. He's stuck on the bottom of that fraction. But I'd still have to deal with this 5r squared and 10r to the 5th. How many r's are being multiplied on top? How many r's are being multiplied on bottom? Who wins, top or bottom? By how many? You said the bottom wins by 3, right? You said the bottom wins by 3. I agree. I agree. I'm going to have to write a cleaned up version of this answer in a moment, but let's deal with the last part, 5 over 10. What does 5 over 10 become? 1/2. Everything has been simplified. Everything has been simplified, but now we are ready to write the final cleaned up version of this answer. What is the only thing left on top of the fraction? Yeah, that sucks. But it's a 1. Don't just leave it blank. And on the bottom, left to right, it's a 2r cubed times r minus 2. And yes, you can leave it like that. That is sufficient. That is a sufficient answer that you could write for this problem. It is insane. I need you to hear a couple things. First, we are going to continue simplifying these problems using multiplication division. Please remind me, what the heck happens when you divide fractions? When you divide fractions. A lot of you were taught differently. Did you ever do keep, change, flip? Yeah, same concept. And we're going to be doing that same concept as well. What the heck do you have to make sure of when you add or subtract fractions? What do you have to make sure of if you add or subtract fractions? Yeah, you have to have a common denominator. We're going to have to deal with that eventually. We're going to deal with that. Today was just multiplying, dividing. Wednesday, we're going to continue multiplying, dividing, and I may begin introducing addition, subtraction problems on Wednesday. But that is where we're headed. Reminders. Thursday, grades are due. You said 8 a.m. I need that stuff turned in a sufficient amount of time so that I have the time to actually get it graded. I still need to go through my inbox. I was inundated with emails today when I came in. I had 104 in my inbox this morning that I have to go through. I think I've gone through about half of them so far. But if you've turned something in and you're like, Ms. Mark, you haven't gotten to it yet, I'm sorry. I literally came back to school today. Cut me some slack. I'm cutting you some slack. So get that stuff into me. We'll see what we can do. And if you have any other questions, of course, you can email me. And we'll knock this thing out. It'd be great. And then we'll high five at a distance. Joe says, I don't know what I'm missing. Joe, email me. Email me. And we can talk about that. Not in the live chat. Joe. Anyway, if you haven't left a comment in the chat, please make sure that you do so. I'm going to be signing off in a few moments because that bell is going to be ringing in approximately 12 seconds. So please make sure that you do. I'll leave it open for a few more moments. When I said 12 seconds, I guarantee you at least 2 of you began counting in your head. All right? There's the bell.